Good morning. Am I audible to you? Okay. Now I'm going to start the class today. Is the first block of this book, Green Chemistry. In this block, we have three units. The first one is Introduction to Green Chemistry and the Principles of Green Chemistry and Applications of Green Chemistry. These three units we are going to discuss today. Now, first, my question is what is green chemistry? Then, what is the green chemistry? A green chemistry is a branch of chemistry which deals with the maintenance of the products and designing of the products in such a way that reduce the environmental hazards and safety priority. That is called green chemistry. As per our book, we can define it as a green chemistry is the design of chemical products and processes that reduces or eliminate the use of generation of hazardous substances. Green chemistry is applicable or applies across the lifestyle of human being. Life cycle of human being, which is human being, those who are using the chemical products, including its design, manufacturing and use, and ultimate disposal. That means whenever we are producing a chemical substance, that chemical substance we need to use it. After that, we need to uh, decompose it. Okay, we need to dispose it. Okay, this disposal process and synthesis process and using process all should be in such a way that should be environmental friendly. Then only it becomes a green chemistry. That green chemistry is a sustainable chemistry. That sustainable chemistry increases the lifespan of the or maintaining a better environment. Okay. Then what is the need of green chemistry? Green chemistry is a necessary thing because whenever we are coming to the chemicals or chemistry part, most of the products used by the human being, these products are sometimes hazardous and sometimes environmentally harmful, sometimes may harm the users also. Due to that reason, whenever we are going to produce a product, and whenever we are going to uh, going to the production of that particular substance, we need to maintain a safety procedures and safety uses. This is the here the green chemistry explain us how to use the products and how to manufacture it in such a way that it should not be harmful to the environment. Okay, this is happening. A revolutionary thing is happening in 20th century. So many of chemicals are coming to the market and people are using that, but they are not aware the what much hazard to or what much harmful to them. But in 21st century, we come to that everyone is thinking about the how much harmful it is, how much it is hazardous to us. Okay, that is the reason here we need there is a necessity thing is green chemistry is required to getting the useful product, those products which will not harm human life cycle or human beings and also environment. Okay, this is the necessary thing. These are the needs of the green chemistry. Now coming to the goals of the green chemistry. What is the goals of green chemistry? Prevent the pollution at the molecular level. Whenever we are going to synthesize a molecule, uh, in the synthesis part, this synthesis procedure will not give the any byproduct or will not remains as unreacted substances in the final product. Whenever we are getting the final product will not include the byproducts or will not include the reactants or catalysts like that. That's why we need to prevent the pollution whenever we are going to use it in the molecular level. Okay. Now the second thing is it is philosophy that applies to all areas of chemistry, not a single discipline of chemistry, because green chemistry is not belongs to only organic chemistry, organic synthesis, organic chemistry design. It is also the part of every area of the chemistry. It may be analytical chemistry, it may be physical chemistry, it may be inorganic chemistry. Everything, everywhere you should use it. Okay. Next, third one is applies innovative scientific solution to real world environmental problems. Today also several problems are there with respect to the chemistry. In the chemicals, whenever we are going to produce the chemical, whenever we are going to use the chemical, whenever you are going to use the uh, uh, decompose the or dispose the product, in all these three aspects, having so many problems are there. How to produce safe manner, how to use safe manner, how to dispose safe manner. Okay, these three things are required. In these three conditions, three cases, we need to apply this innovative scientific solutions in such a way that the solutions gives the clear solution to protect the environment. Okay, next. Fourth one is result in source reduction because it prevention that generates the pollution. Whenever we are going to synthesize or whenever we are going to use, during the usage or during the synthesis, it may cause us the pollution. Suppose whenever we are burning the diesel or petrol, it causes the environmental pollution. Now here the green approach is we are going to use the electric vehicle in such a way that here the chemicals are also whenever we are going to produce the chemical products or using the chemical products, we need to adapt the green procedure, though green procedure wherever the source is there, the source is causes the pollution or the causes the hazardous. We need to prevent that. We need to prevent that is the results in the source reduction, source pollution reduction. That causes the we decreases the generation of the pollution. Next, third one, reduction, reduce the negative impact of chemical products and process on human health and the environment. We have seen several chemical accidents. Chemical accidents are there, or chemical pollutions are there, which are generated from the industry or which are generated from the somewhere else. Okay, all these are basically affecting on the environment and human health and animal husbandry also sometimes are not, sometimes many cases on the animal husbandry also. Okay, we need to everywhere we need to reconstruct the procedure, reconstruct the usage, reconstruct the disposal manner. All these things are helpful to reduce the negative impacts on of chemical products and processes on human health and other environmental impacts. Okay. Next, lessons and sometimes eliminate the hazard from the existing products. We have several millions of compounds, chemical compounds are there. We are going to synthesize, we are going to use in several manners. These are all well-known procedures. Even though they are well-known procedures, during the synthesis, during the production, we are getting so much wastage, so much hazardous wastage is generated. Due to that reason, those procedures are sometimes we treated as a not suitable procedure for their production. Those procedures we need to convert into green procedures in such a way that we need to decreases the or eliminate the hazards from the existing production processes. Okay, next, designs chemical products and processes to reduce their intrinsic hazard. The same thing. The product, chemical product or processes. Whenever we are going to design it, we need to keep in mind that we need to eliminate any kind of hazard, any kind of byproduct. That will automatically reduces their instinct hazards. Okay. Next, what are the limitations and obstacles in the pursuit of the goals of green chemistry? Whenever we are going to achieve these goals of green chemistry, several hurdles are there. We need to overcome it. We need to remove it during the case of whenever we are going to achieve the green chemistry goals. Okay. First thing, availability of green technology. For every case, green chemical technology may not be available, but we need to develop it. We need to develop it. It sometimes takes much time, but we need to develop wherever it requires, because in the conventional procedures may give the more amount of hazards, more amount of wastage, more amount of impacts on the human life and environment. Therefore, we need to avoid it. We need to avoid it. Further avoiding these procedures, we need to develop several procedure technology, green technologies and green procedures. Okay. Suppose till now the nitration, sulfonation, Friedel process, alkylation, and acylation type of reaction, there is no green procedures. There is no perfect industrial adaptation uh, type of procedures are not available. We need to develop it. Okay, that is the that means whenever we are going to converting into green technology, green mode of synthesis or green mode of production, that availability is also important. The availability of green technology is also important. Okay, all these conventional procedures of nitrogen, sulfonation, fuel alkylation, such procedures involves as it's has a very strong acids and alkali solutions and hazardous reagents. All these are very hazardous to the environment and also sometimes during the usage it affects on the human being also. Okay, scale up commercialization. Actually, researchers and academicians are developing some green technologies, green procedures, but these green procedures are not up to the mark of industries up to the mark of industries. Therefore, there is so many of processes are not commercialized. So many processes are not commercialized, even though green technology is available. Because sometimes it may be expensive. Sometimes the starting materials may not be available in the commercial manner. Due to that reason, whatever the green technology we have developed in the academic and research institutions, we need to develop to the commercialization steps. Okay, we need to take into the industrial level. Okay, that is the second thing. And third one is connecting green chemistry solution provide to industry. The same thing is here. There are many green chemistry solutions are available and are also proven. One of the key limitation is there is a lacking of relation between the academic and research group to industry. There is a this relation gap is there. Due to this relation gap, we are not able to provide this exact what is required for the industry and what is required for the what type of research and what type of work is need to conduct in the academic and research institution. This is a relationship lacking between the industry and the academic and research groups. Okay, research organization. This is the one. Next, understanding of basic principle. This is the first thing actually we need to discuss it. Whenever we are going to converting every technology into green technology, we need to understand the green chemistry principles. Then only we can develop the green chemistry technologies or green chemistry procedures. Okay. Therefore, whenever we are going to attempt the developing the green technology for a procedure or for a product, we need to thoroughly understand the principles, basic principles of green chemistry. And fifth one, green chemistry is not economical because green chemistry is a costly and complex and not viable for SMEs. Small scale industries, it is not viable. A large scale industries they can develop, they can adapt the procedure, they can alter the procedure for decreasing the cost expenses and the time expenses and the energy expenses. But the small scale industries, they are the starting in the position. Therefore, they are not able to invest on that. That is the reason green chemistry is a good theory and practically not feasible for so many times. So many times. Therefore, the green chemistry is difficult and complex. This is not viable for small and medium scale organizations. It requires huge resources. Is it maybe energy or funds in manner, everything. We need to we need to keep in mind that whenever we are going to apply the green chemistry or green chemistry technologies, further alteration is required. That alteration consumes so much amount of time and wealth also. Okay, that is the reason green chemistry is costly and complex, not viable for the small and medium scale industries. Okay, next regulatory hurdles. Regulatory hurdles means suppose for a industry producing a paracetamol tablet, they are adopting a conventional process. That conventional process is approved by some some authorities like foreign drug authorities and Indian drug authorities, controlling authorities like that. They have the certain procedure is there for the validation of the process, for the validation of the purity, for the validation of the quality. Okay, whenever we are going to apply the green chemistry technologies, these procedures need to be changed. This procedure need to be changed. All the validation procedures are changed by the these FDA and drug controlling authorities. Therefore, there is a difficulty, there is a hurdle. We need to switch on to the new process of validation. Therefore, it takes so much of time to adaptation. Okay, this is the regulatory authorities. Now, this is about the first unit. In this first unit, we are discussed about the what is the green chemistry and what is the its need and what are the goals of the green chemistry and the limitations of the to achieve the goals of the green chemistry. And next, coming to the second unit, the second unit is principles of green chemistry. Here well, I'm going to directly to the principles. The principles of green chemistry. These are there are 12 principles are there. These 12 principles are proposed by and developed by Paul T. Anastas and John C. Warner. Okay, these two scientists are developed 12 principles. Whenever we are going to develop a green technology or green process, we need to keep in mind that these 12 principles are very much important. Um, when we call it green process or green synthesis, that should be satisfy at least the 6 to 7 rules of the green principles. Okay, what is that? The first principle is uh, prevention of waste or byproducts. I've already discussed. Then only it is a green synthesis or green process. Whenever we are going to design a synthesis of a product, we need to eliminate the byproducts and the waste. Or at least we need to reduce the amount of byproduct and the amount of waste. That is also green technology. Okay. The second thing is maximum incorporation of reaction into the final product. Reactants into the final product. Suppose here there is a and B. Both reactants are reacting together. They are after the reaction they produce the A and B. Now A and B both are incorporated into the product. Therefore 100% incorporation is takes place. In every case it is not may not be possible. But we need to keep in mind that whenever we are going to plan a synthesis, the maximum amount of reactants incorporated into the product. Then only that is the economical green chemical reaction. Okay. Now the third one is prevention or minimization of hazardous product. Okay. In the first step, we have decreases the amount of byproducts or eliminate the byproducts and also decreasing the amount of waste and the amount of uh, whatever the other products obtained along with the product. But in the third one, we are going to specifically discuss about the hazardness, whatever the byproducts and whatever the waste is generated here, that should not be hazardous product. It should not be hazardous product, or at least we need to minimize the hazardness of the product. Whether it is our required product or the byproduct or waste should not be hazardous, or at least we need to decrease the uh, capacity of hazardous. Okay, or intensity of the hazardous. Okay, then the fourth one is design of safer chemicals. This is very much important because whenever we are going to design a synthesis, we start with the environmentally safe as well as safer for the chemist also important. Okay, after usage of the safer chemicals in the synthesis, the resultant product is also safer. Safe mustard should be safe. Mustard should be safe in manner to the user, those who are working on that, and it should be also should not be hazardous to the environment. That means designing of safer chemicals. Next, fifth one is energy requirement for any synthesis should be minimum. We know that in the chemical reactions which are going by the at the room temperature or the photochemical reaction or by heating. These are the conventional process. In this conventional process, some kinds of reactions require so much of amount of heat and energy or so much amount of light irradiation. Whenever we are going to plan the synthesis, these energies should be minimized. Energy should be minimized. How these energy should be minimized? So we have several processes. Whenever sometimes we are going to add the catalyst, sometimes we add the other alternative energy process, energy sources we are going to use here. Okay. Next, select the most appropriate solvent. Okay. In the chemical synthesis, most of the reactions proceeds to the solvent medium. Solvent medium. That solvent should not be environmental hazard and that should be eco-friendly. For example, if we are going to use the water, water is the eco-friendly solvent. Therefore, whenever we are going to plan a synthesis, environmentally or eco-friendly solvent should be preferable. In worst case, you should use the other solvent. Okay. Next. Seventh rule is selecting the appropriate starting material. Here, the starting material is also important. Starting material, without a proper starting material, we cannot achieve the final product. Okay. Next. Eighth one is use of catalyst should be preferable whenever whenever is possible. Okay. What is the use of catalyst in the reactants? Catalyst is minimizing the energy requirement and speed of the reaction. These two, because of these two cases, two reasons, we are going to use the catalyst. Minimum, first basic reasons for the usage of catalyst is these two reasons. One is it minimizes the energy, and the second one is speed of the reaction. These two, because of these two conditions, we are going to use it. Okay, wherever it is possible. Suppose for a particular reaction, there is a not available of catalyst. We need to search it and develop the new catalyst and use it. Then only we can utilization of the energy is minimized. That is environmentally friendly. Yeah. Now, this is the eighth principle. What is the eighth principle? Seventh principle is selecting the appropriate starting material, and the eighth one is use of catalyst. That is also discussed. Next, the ninth one, products obtained should be biodegradable. Whatever the products we are going, our target is there. The target of achieving, we are going to use it. After the usages, it should be biodegradable. Okay, that is the ninth rule. And tenth one is use of protecting group should be avoided whenever it is possible. Okay, what is the protecting group? Protecting group is, suppose if a particular reactant is there, in a particular reactant, two or more functional groups are there. But our reaction is going to work on the one particular functional group. The remaining two functional groups are also involving in the reaction. In such case, we need to cover it, cover the remaining two functional group with the by converting the other form of the functional group. That is called protect. We are capping the functional group. The capping means the protecting of functional group. Okay. The protecting group usage requires the additional steps of reaction. Whenever we are going to use the protecting groups, then therefore the number of steps of the reaction is increases. Due to that reason, we need to avoid the use of protecting groups in a reaction. Okay, the reaction process should be designed in such a way that without using the protecting groups. Next, the 11th rule is manufacturing plant should be so designed as eliminate the possibility of accident during the operation. Okay, it is a very much the 60% important thing is in the manufacturing industries is we need to design well mannered plant. Okay, production plant, because if it is not the prescribed manner, there is a possibility to occur several number of accidents. Several number of accidents. We have seen recently so many fire accidents in the GD Metla IDA and some Bolaram IDA like that. What is the reason? There is a compressed in manner. There is a compressed in manner under in the small places they are taking so much operations are there. Due to that reason, it causes sometimes contamination, sometimes the accidents are regularly happening. That is the reason whenever we are going to construct a production plant, it should be a spacious and prescribed manner of design. Okay, that is the 11th rule. And the 12th rule is strengthening of analytical techniques to control the hazardous products. Excuse me. Next, strengthening of analytical techniques is very much important, because whenever we are designing the product or whenever we are going to synthesize the product, we need to monitor the process, entire process, in such a way that where the process is completed, we can identify exactly. Due to that reason, we can uh, we can save the energy, we can save the time, as well as we can also monitor the formation of hazardous products along with our required products. Okay. Then, therefore, to improve all these things, we need to develop the new analytical techniques. Those analytical techniques are helpful to control all the hazards which are producing along with the product. Okay. Next, designing a green synthesis and the prevention of waste or byproducts. Okay. Here, in every case, not only the green chemistry, we can also keep in mind that whenever we are going to conventional synthesis of any compound, we need to reduce the byproducts and waste along with the required product. Because whenever the byproduct is formed in a reaction, in a process, it is also decreases the yield of the product. Whatever the desired product is there, the desired product yield is decreases. Okay. Along with the yield is decreasing, we are wasting the starting material amount. Okay. Therefore, this impacts on the cost effective and time effective and energy. These things are highly effective during the synthesis whenever it is involving the formation of so much of waste and byproducts. Okay, the first thing, yield is calculated with the actual yield of the product by the whatever the amount of product is obtained in the reaction synthesis process, and whatever the theoretical calculation, the amount of the product is obtained from the calculation by the theoretical process, that is actual yield of the product by the theoretical yield of the product into 100. That is the yield of the product. Okay. In this yield is clearly indicates that the utilization of the atom when during the reaction, atom utilization is important. Atom utilization is important. Suppose the reactant is converting into product. Suppose the reactant is having 100 atoms. Whenever the product is produces, it is only having 80 atoms. 20 atoms are wasted. That is the atom utilization. That is called atom utilization. The percentage of atom utilization is calculated with the molecular weight of the desired product by molecular weight of desired product plus waste or byproduct into 100. That is the atom utilization. Now, uh, second more important thing is atom economy. Atom economy. This is explained by the B.M. Prost and the second R.A. Sheldon. These two people are explaining the atom economy in the green chemistry. What is the atom economy? Atom economy explains the how much of atoms are converting into the from the reactant to the product. Okay. This atom economy is also explain the economy of a reaction also. How much of economy is utilized? Suppose 100 rupees are we are investing on the reaction. Suppose the 80% of the product is obtained. Therefore, 80 rupees of um, 80 rupees amount of product is retained, but the 20 rupees of amount of the waste product is wasted, and also funds are also wasted. Therefore, it is also helpful for the atom economy is also helpful for the calculation of yield, calculation of the viability of the reaction also explained. Okay. Next, calculation of the atom economy of the rearrangement, addition, subtraction, and substitution. Sorry, substitution reactions or elimination reactions. First, coming to the rearrangement reaction, wherever we are coming to the rearrangement reactions are 100% atom economy reaction because there is no loss from the molecule. There is no loss from the molecule. Suppose if we consider the Claisen rearrangement reaction, in the Claisen rearrangement reaction, this reaction involves the conversion of just this group. This particular group is rearranged from this position to this position. Okay, that is allyloxy. Benzene is converting into 2-prop 1-in 1-allyl phenol or ortho-allyl phenol. Okay, this is the product. Now, suppose the 100 molecules of this reactant is converting into 100 molecules of this product. Therefore, this reaction atom economy is 100%. Okay, now next, addition reaction. Addition reactions are also producing, showing 100% economy. So, whatever the reaction previously shown, A plus B, both are undergoing addition reaction. They produces the A and B. Here also, the propene is undergoing addition reaction with the H2 in presence of nickel catalyst. The nickel catalyst is recovered back. Now, the product is nickel here. The propane plus H2 produces propane. Propene is produces propane. Now, the two hydrogens are added to this one. Therefore, this reaction atom economy is 100%. Okay. Now, Diels-Alder reaction. We coming to the Diels-Alder cycloaddition reactions are Diels-Alder reaction. Diene. Both are undergoing cycloaddition reaction in presence of microwave conditions. This is the microwave energy power. Then it leads to formation of cyclohexene. This is also 100% atom economy reaction. And the bromine addition of the propene is also dibromo product formation is also 100% atom economy reaction. Now coming to the substitution reactions, wherever you go, the substitution reaction, one group or one atom is replaced with other group or other atom. Okay, during the reaction, at least one group or atom should be eliminated from the or leave from the molecule. Therefore, these kind of reactions will not give the 100% atom economy reactions. Okay, so whenever we are coming to ethyl propionate and N-methyl propionate or methanamide or ethanolamide, these atom economy is most of the cases here this NH2 is eliminated. Both are undergoing the reaction. Here OCH OET is eliminated from the ammonia group, hydrogen is eliminated. Both will combine to produce ethanol. Ethanol is eliminated. This is the byproduct. This is the byproduct. This is the our desired product. Okay. Therefore, its atom economy is almost after the calculation, you can study it is, yeah, 64%, 65.4% of atom economy. That kind of reaction. Okay. Now coming to the elimination reaction. Elimination reaction is also elimination of one group or atom. Elimination of one group or atom. Therefore, from this we look at this. Here the elimination, the breakdown of this bond, it leads to the formation of propene and trimethylamine and water. Okay, one molecule is bifurcated into three molecules. Therefore, atom economy should be dropped down. Its atom economy is 35.3% only. 35%, 35.3% only. Okay, that is the atom economy and atom utilization in the reaction. Okay, designing a green synthesis in such a way that minimization of the byproducts. Okay, preservation and minimization of hazards are toxic products. Okay, this is explained by the one function risk is equal to F into hazard exposure function. Okay, now the most important principle of green chemistry is prevent or at least the minimization of the formation of hazardous product, which may be toxic to the environmental and harmful to the environment. The risk associated with the toxic chemical is explained in the following this function. Okay, and also one of the rule is there. End of the pipe is law. There is a law to control the risk of the any process or prevent the any process or prevent the toxic or hazardous substances which are produced in the process. Okay. Next, green solvents. We have several green solvents are there. These green solvents helpful to saving the energy and saving the reactant to converting in most amount to converting into the product. Okay. Here there is a liquid or supercritical liquid of carbon dioxide and is a green solvent. And water, aqueous phase is also water medium is also a good solvent. And without the use of solvent, any reaction we are going to conduct without the use of solvent, that is called neat reaction. That is simply called as neat reaction. Okay, neat reaction is also very much important for the green synthesis. Okay, and the solid phase synthesis is also important. These three cases are green solvents. This is the critical liquid solution or supercritical liquid for carbon dioxide, liquid carbon dioxide, and aqueous. That is the water mediated reactions and solvent free reactions and solid phase reaction. All these four cases are we call it as green processes. Okay. Now and other kind of green solvents are liquid ionic liquids. Ionic liquids are it is in the form of two ions, one anion and one cation combined to form monobasic salts. And suppose binary ions are there, but dibasic cation and dibasic anion both will combine to form a salt. That is a dibasic salt. Such kind of substances are used as ionic liquids. These ionic liquids are helpful to achieving the good to green conditions. These reactions in ionic liquids are easy to perform and no need special apparatus and methodologies. And also ionic liquids can be recycled at this leads to reduction of the cost of the green process also. Okay, ionic liquids whenever we are going to use in the reaction, it can perform very effectively. We can recover it. After recovery, we can use it in other reactions. So therefore, then they can influence on the costs of our economic conditions of the reactions are also okay. Chlorobenzene and fluorobenes, that is the fluorous bibatic solvents. These are also green solvents, and the PEG is also green solvent, and the immobilized, that is non-volatile solvents, is also green solvents. Solvent process. So, for example, you take the simple reactions which are directly subject to the heat or under photochemical condition, they lead to the product. That those are called without using the solvent. Those are called solventless processes. Okay, immobilized solvents means the solvents are not volatile, non-volatile, and these are not when they are not volatile, they are not contaminated with the environment. Therefore, they are these are not exposed to the human beings or us. Okay, therefore these are not hazardous to the these are not hazardous substances. Next, energy required for the green synthesis. Energy required for the green synthesis. We are using three kinds. Conventional, we are using heating and irradiation of light. Okay, the irradiation of light is also green process, but whenever we are going to heat, sometimes the reaction may be required high temperatures heating. That means sometimes the reaction may take place above 250 or above 180 degrees. These reactions require the heating coils and heating liquids, the heating oil, silicone oil, and sometimes we are going to use sand baths like that. It may take the time-taking process for getting the achieving the required amount of heat energy, and also it causes sometimes accidents in the work area also, industry or in the lab also. Okay, due to that reason, to avoid that unnecessary things, we are going to use two kinds of alternative things here: the microwave energy and the ultrasonic energy for achieving the green conditions. Okay, in the microwave, we can it is very more efficient source for the heating than the conventional process. Whenever we are going to heat the substance in a vessel, directly the microwave energy is absorbed by the substance, but vessel will not be heated. At that moment, the reaction containing contains absorb the heat energy from the microwave, then it leads to the converting into the or transforming into the products. Similarly, the ultrasonic energy is the electrical and mechanical energy that is converting into sound energy. That sound energy, whenever we are hearing the powerful sound energy that is applied to the chemistry, that is called sonochemistry. In the sonochemistry, this sound energy, whenever we are providing the sound energy to the chemical substances energy, they are absorbed that energy and converting into chemical energy. Then they are undergoing some chemical transformations that leads to the formation of products. Okay, there is a detailed internal mechanism is there. Whenever we are coming to the practical, we are going to discuss this on chemical chemistry. Okay, next, selection of starting materials. Selection of starting materials. Most of the cases, the selection of starting materials will not be a big deal because always the synthesis involving the starting material should be a simpler things. Simpler things means we are going to start the synthesis of a particular molecule. We start with a small molecule that is readily available and also the readily available from the natural resources or from the renewable resources. Then we start with that. Then slowly we are converting into our desired product. That is called selection. That is the important thing for the selection of the starting material. Okay. Now here we are going to catalyze synthesis. Here, whenever we are going to selecting the starting material, we should not use the protecting group. What is the protecting group? Suppose here we see here 3-hydroxy or meta-hydroxy benzaldehyde. Whenever we are going to react with the benzyl chloride, then it is here. Whenever we are going to conduct the oxidation of the aldehyde, but whenever we are going to conduct the oxidation, this OH is also reacting with that. That is the reason we need to protect this OH group by reacting with benzyl chloride. Then benzyl chloride is converting into benzyl ether, benzyl phenyl ether derivative. After that, we are going to conduct the oxidation reaction. Then is converting into corresponding COOH. It is a COOH. Now it leads to the formation of uh, after that our desired product is generated, then it is reacting with the uh, treating with the HCl solution. Then this carbon oxygen bond will be broken down into the corresponding alcohol. Then our desired product is generated, and whatever the protecting group we have previously used, that is generated here. Now here, for the protection one step and the deprotection second step. These two steps, additional steps are required. Whenever we are going to plan the synthesis of the substances, we need to avoid the usage of protecting group. Due to that reason is two more steps are, at least minimum two more steps are increasing whenever uh, the starting material without using of protecting groups. Okay, therefore that leads to usage of excess amount of energy, or more amount of time, and more number of reactants. Okay, that is the reason it is not economical for a particular process. It should be economical when a suitable reactant should be selected for the achieving the required product. Okay. Now, next, usage of catalyst. You know that the catalyst is facilitate the transformation of or conversion of the product, starting material into the product by minimizing the energy and speed of the reaction. Okay. Uh, in the green processes or green synthesis, catalyst is very mandatory, not mandatory, but whenever it is possible, you need to use it. You need to use it. That then it minimizes the uses of energy, and time the time taking for the process is also minimized. Due to that reason, we need to use it. We have two types of catalysts are there: homogeneous catalyst and heterogeneous catalyst. And the homogeneous catalyst, most of the cases, it proceeds through the liquid phase. But heterogeneous catalyst, it is maybe liquid solid, or gas solid, like that. Heterogeneous phases. Next, homogeneous catalyst proceeds under low temperature, but heterogeneous catalysis takes place under higher temperature. Uh, Homogeneous are highly selective because all the substances are in the same medium. Therefore, the approaching of the reactant and starting materials and our reactants are very much easy. But in the case of heterogeneous catalysis, the approaching or availability of the starting material with the catalyst is decreases. Therefore, the transformation process or transformation rate is decreases. Next, easy heat transfer. The phase is only one phase in the homogeneous catalysis. Therefore, the heat transfer takes place in very easy manner. But in the heterogeneous catalysis reaction, two or three phases or more phases are available, are existing in the reaction part. Therefore, the heat requirement amount will be phase to phase decreases. Therefore, differs. Therefore, that is the reason the heat transfers uh, varies from phase to phase. Okay, that is the reason it can be an issue. Okay, now fifth one is difficult to catalyst separation. This is the only difficulty in the homogeneous because in the homogeneous catalysis, catalyst is also dissolved in the reaction phase. Therefore, the recycling of catalyst is very much difficult to. But in the case of heterogeneous catalysis, catalyst is easily separated just by filtering or just by extracting. But in the case of homogeneous catalysis, it is the extensive recycling because all the substances are in the single medium. For the converting in separable manner, it requires the extraction or treatment of other solvents and treatment of other substances is required. Therefore, it is the extensive recycling method. And in the heterogeneous process, all the phases are easily separable. Therefore, simple recycling process. And seventh one is well-defined active sites. Where we know that how the homogeneous catalysis is takes place, but it is the heterogeneous catalysis is not a well-mannered understanding process. Therefore, it is poorly defined. And eighth one is easy catalyst modification. We can modify the catalyst easily, but it is very difficult to catalyst modification in this case. Okay, because the heterogeneous catalysis, the catalyst has a specific role. That specific role, whenever we are going to change the morphology or structured arrangement of the catalyst, its role will be changed. That is the reason that it is difficult to modification, but it is easy to modification in the homogeneous catalysis. Next, the reaction mechanism is well understood, is already discussed. That it is the in the case of heterogeneous catalysis, that is a poorly understand. Then all these are heterogeneous catalysis or homogeneous catalysis in the case of whenever we are using the chemical substance. Suppose if we are using the catalyst as the bioproduct, that is called biocatalyst. The biocatalyst may be used in the bacterial and fungal or other microorganisms influence the process that is called biocatalytic reactions, and the substance which is involved in that microorganism reactions are called the biocatalyst. Various organic reactions such as oxidation, reduction, hydrolysis are more reactions are influenced by this biocatalyst. The best examples of biocatalysts are enzymes. Enzymes are specifically act on the organic molecules or any other chemical substances. They converting into specific compounds. Okay, we have several examples are there. Uh, Here, these three things are you need to understand that the most of the reactions are performed in aqueous medium. Okay, this is the green process. Suppose the reaction is carried out in a water medium or aqueous medium, that is a green process. The biocatalyst conversion was the only one step. It is not requiring multiple steps. Only single step reaction is required to convert the starting material to the product. Therefore, it is also green process. Next, the production and reproduction of the functional group is not necessary. This is the major difficulty of the green chemistry or chemical synthesis, because wherever the production and reproduction is required, additional steps are required. Therefore, it is not necessary in the case of biocatalyst process. Therefore, it is also green process. The reactions are fast when we compare to the others. Therefore, it is also energy requirement and time consumption is also decreases. Therefore, it is also green process. Okay. Now, biochemical oxidation. Here we take the ethanol is undergoing the oxidation with the oxygen and the bacterium acetic. Then it is converting acetic acid. Next, the simple sucrose is converting into glucose and fructose with the water in the form in presence of invertase and R yeast. The zymase is converting into glucose into ethanol and carbon dioxide. Next, asymmetric synthesis, asymmetric catalyst. We are already discussed it in the asymmetric synthesis. What that means, a catalyst is reacting with a reactant that is converting into a chiral compound. Then it is called asymmetric catalyst. Next, photocatalyst. A large number of conventional syntheses have been carried out photocatalysis reactions. Practically, here the titanium oxide is used for the photocatalyst systems. It is important for the purification of water, polluted water, and decomposition of offensive atmospheric order as well as toxic. The function of CO2 and the decomposition of the chlorofluorocarbon is also huge global used in the large scale. That is the much global problem also. Okay, chemical accidents and prevention. I have already discussed previously. Whenever we are going to design the plant, production plant, it should be designed well manner. Otherwise, accidents are frequently occurred, encountered, and this is the best example for the Bhopal gas tragedy. Here, the process defective. This Bhopal gas tragedy involves the process defective or process difficulty. For the synthesis of carbide, there is a requirement of um, this carbide is a pesticide. There is a requirement of methyl isocyanate. This methyl isocyanate is produced from the phosgene and methylamine. Methylamine is reacting with the phosgene. Both methylamine and phosgene, both are the very hazardous chemicals to the environment. Due to that reason, these are stored in the high pressure containers. These high pressure containers, whenever at the combining chamber there is a leak, due to that leak, that this isocyanate is uh, isocyanate is leaked to the environment. They form a cloud, and actually, as per the calculations, 5 lakh people are exposed to the accident, but 20,000 people are died due to the uh, severe damage, and till now 1,20,000 people are continuing suffering from that. Okay, this is the very tragic accident due to the difficulty in process for the maintenance of the methylamine and phosgene gas. Both are hazardous chemicals, but we are modifying by using the inheritance safer design process. This by using the inheritance safer process is converting the conventional process into safer process by using the green technology. That is called, this is the main principle of this IST, that is inherent safer design. Here, uh, there is an alternative procedure for the carbon synthesis. There is a alpha naphthol one naphthol is there. That one naphthol is treated with the 1,3 dimethyl urea. Simply, it is converting in carbide. This is the carbide. Okay. There is no usage of methylamine and there is no usage of phosgene. Therefore, whenever we are not going to use the phosgene and methylamine, there is no hazardous chemicals are using in the synthesis or production. Therefore, all the safety risks, whatever the safety risks are, the expensive safety maintenance equipments are not required. Therefore, it is the process is simplified by using the green technology. That is the greatness of the green technology. Next, flexibore accident. This is the flexibore accident is due to the high pressure cyclohexane tanks. It is happening in the England Flexiboro area, a village of Flexiboro of England. It is England. Okay, there is a large pressurized tanks are stored in Flexiboro. The tanks contains the cyclohexane. That cyclohexane is oxidized to cyclohexanone and cyclohexanol. This for this process it requires the high amount of pressure. These are linked to the six loop reactors. In the six loop reactors, the reactor 5 is leaked due to that leakage of pressured gas from that fifth reactor. Now immediately it catches the fire. That fire, due to that fire, the explosion is happening in a large scale, almost 50 kilometers radius. It is affected. Then to avoid that pressure tankers, there is a safer procedure is designed. In this process, just directly taking the cyclohexene, the cyclohexene is converting into cyclohexene epoxide. The cyclohexene epoxide is converting into cyclohexanol. Later, it is undergoing elimination. It is a cyclic process. It is a cyclic process. We can design it. Okay. Now, by using the ISD, you can divide into this subdivisions of ISD. The subdivision of ISD, that means inheritance safety designs, having five subdivisions. One is minimization, simplification, substitution, moderation, and limiting. Whenever we are going to design the process, minimize the hazardous materials and simplification the process, and substitutions means wherever the hazardous starting materials are, we need to substitute with the non-toxic and non-hazardous materials. And moderation, we need to modernize the reaction conditions. That means whenever it is reacts, the new methodologies are required. Suppose whenever we are going to combusting the solid waste in the form of powder, it leads to the formation of huge fumes to the environment. Whenever we are going to prepare the pellets of that material, that pellet is combusting, there is no such kind of fumes are dust and fumes are not avoided into the atmosphere. And the limitations are some wherever the conventional process, the limitations are there. Those limitations we need to overcome by using the ST processes. Next, development of analytical techniques. This is a development of analytical techniques. We have previously I have told that I have explained that advanced analytical procedure can helpful to decreasing the hazardous materials and also in effectively maintaining the energy and time. Okay, this is the thing we need to develop the new things. Next, this is the second unit. And going to third unit, that is I'm going to brief the 5 minutes. Okay, green synthesis of some reactions. Here the several reactions are there. In these all these green reactions, we are going to use the starting material which are available from the nature and from the renewable sources. The first synthesis of adipic acid, the synthesis of adipic acid is starting with the D-glucose. D-glucose is readily available in the market. It is readily isolated from the nature. Then this D-glucose is converting into the corresponding carboxylic acid. Carboxylic acid is converting into catechol derivative, catecholic acid derivative. Then it is converting into catechol. Then after that, it is converting into cis this muconic acid. Then this muconic acid is converting into adipic acid. Next is synthesis of catechol. Same. This is the half procedure involved in catechol. This is the catechol synthesis. Okay, that is the completely um, green synthesis. Okay, diethanol amine. Diethanol amine. It is treating the sodium hydroxide co-catalyst. Then it is converting into DSIDA. What is the DSIDA? This is the disodium imino diestate. Okay, this is the alternative for the Stecker synthesis. Stecker synthesis requires the hazardous acids and alkali materials. We are going to avoid it here. Next, micro-assisted reactions in water. Off-min elimination reactions are there, and methyl benzoic acid conversion in the water medium, that is the aqueous medium, and oxidation of toluene into the carboxylic acid, that is the benzoic acid in the water medium, and the microwave-assisted synthesis, and oxidation of alcohol, that primary alcohol is converting into carboxylic acid in the water medium, that is we are going to use peroxide, and the microwave-assisted reaction in presence of carbon solvent, that is the diol solder reaction. This takes place in xylene or other kind of organic solvents. Okay, just anthracene is converted. This is act as a diene and it is acting as a malalkyl is acting as a dienophile. Then it produces the adduct. Next, decarboxylation. Decarboxylation of this indole carboxylic acid in the microsynthesis. Then it is the neat reaction which we are not at all using any solvent. Just simply heating it, then it undergoes decarboxylation, produces the 6-methoxy-indole, the 99% with 99% heat. Next, ultrasonic acid reactions. In the ultrasonic acid reactions, Siemens reaction, the cyclopropane derivative will be obtained. Okay. Just the methyl ester of this fatty acid is treating with the zinc and methyl iodide. At the 5 kilohertz of sonication, it leads to the formation of this propionic acid derivative. Next, applications of green chemistry. Designs of environmentally and safe marine materials. Okay, there is a difficulty in the marine boat production. Build up a boat or ships. There is a difficulty to some pollen like fungus and bacteria, they damage the boards. There is a coating material is synthesized by the green process, that is Ronan has developed. This is the material. These materials uh, paintings are used for the protection from the bacteria and the fungus which are arranged in the uh, which are brewed at the surface inner surface of the boat or ships. This will be prevented. Therefore, it will reduces the maintenance cost of the ships and the marine accessories. Okay. Next, the second thing is an efficient green synthesis of compostable and widely applicable plastic. Polylactic acid. It is isolated. It is taken from the corn material. It can be used for the. It is actually biodegradable plastic. This biodegradable plastic is used for the uh, food covering and food delivery materials, and it is 100% green material, 100% green plastic. It is 100% biodegradable and 100% green material. Okay. Next, right fit pigments. These three right fit pigments are used for the pigments. Azo pigments are there. These azo pigments are replaced with the metal pigments which are going to use in the food production. Okay, food production involving the several kinds of metal based pigments are used for the color purpose. These red fit pigment, scarlet, this type of azo pigments are replaced with the metal pigments. Okay, next, healthier fat and oil by green chemistry. Enzyme interestation process helpful to the conversion of the trans fat and uh, production of no trans fats and oils. That means oil is converting into say green oil. Okay, healthier oil is converted by this green process by using the enzymatic intensification process. Okay, this is about the green chemistry. Now tomorrow we are going to discuss about the environmental chemistry 1 and 1 2. Okay, thank you.